सो हेलो बच्चा लोग, मैं गौतम कुमार फ्रॉम आईआईटी हैदराबाद आज लेके आया हूँ 12th क्लास का रिवीजन सीरीज़। तो बेसिकली मैं यहाँ पे आपको एनसीईआरटी का पूरा सिलेबस 30 डेज़ में करवाने वाला हूँ रिवीजन, ठीक है। तो बेसिकली माय एम इज़ दैट कि मैं आपको सभी टॉपिक्स के साथ साथ उनके कुछ एग्जाम्पल जो इंपॉर्टेंट हैं वो सब आपको इस रिवीजन सीरीज़ में करवाऊँ। तो बेसिकली हमारा चैप्टर फर्स्ट से हम स्टार्ट कर रहे हैं आज, और मेरा टारगेट है कि मैं 30 डेज़ के अंदर आपको ये पूरा रिवीजन सीरीज़ कंप्लीट करा दूँ, ठीक है। तो हम स्टार्ट करते हैं हमारा रिवीजन सीरीज़। तो बेसिकली हमारा फर्स्ट चैप्टर से स्टार्ट कर रहे हैं हम, जिसके अंदर हमारा फर्स्ट टॉपिक है इलेक्ट्रिक चार्ज। तो बेसिकली चार्ज क्या होता है? चार्ज इज़ एन इंटरनल प्रॉपर्टी ऑफ एनी मैटर, ओके। चार्ज इज़ दैट प्रॉपर्टी विच इज़ एसोसिएटेड विद मैटर ड्यू टू विच इट प्रोड्यूसेज एंड एक्सपीरियंसेज इलेक्ट्रिक एंड मैग्नेटिक इफेक्ट्स। मतलब कि जिस भी इफ़ेक्ट के कारण हम इलेक्ट्रिक फील्ड का लाइक अट्रैक्शन या रिपल्सन देखते हैं, तो वो सब इफ़ेक्ट के किस लिए होते हैं? वो चार्ज के कारण ही होते हैं। तो बेसिकली हमारा चार्ज जो है, इसकी खोज की गई थी फ्रैंकलिन के द्वारा। फ्रैंकलिन ने इसकी खोज किया था। नाउ चार्ज इज़ टू टाइप्स, लाइक चार्ज आपका पॉजिटिव भी हो सकता है एंड नेगेटिव भी हो सकता है। तो चार्ज के दो टाइप हो गए। नाउ कंडक्टर्स एंड इंसुलेटर। तो देखिए, कंडक्टर्स और इंसुलेटर में क्या फ़र्क है? कंडक्टर में आपका जो चार्ज होता है वो फ्री चार्ज अवेलेबल होते हैं, फ्री इलेक्ट्रॉन्स अवेलेबल होते हैं, जबकि इंसुलेटर में कोई भी फ्री इलेक्ट्रॉन या फ्री चार्ज अवेलेबल नहीं होते। तो बेसिकली फ्री चार्ज आपके सरफेस के ऊपर आ जाते हैं और सरफेस के ऊपर मूव करते हैं, जिसके कारण उन्हें कंडक्टर्स बोला जाता है। वो कंडक्ट कर सकते हैं, लाइक वो इलेक्ट्रिकली या फिर कहीं की लाइट को फ्लो करते हैं बेसिकली, ओके। नाउ द नेक्स्ट टॉपिक इज प्रॉपर्टीज ऑफ चार्ज। नाउ we have many properties of charge. Basically now we are starting. First property is that charge is a scalar quantity. Means अब पे जो है चार्ज है उसका कोई डायरेक्शन नहीं होता। चार्ज इज़ ओनली इन द मैग्नीट्यूड फॉर्म। चार्ज का क्या होता है? सिर्फ मैग्नीट्यूड होता है, इसलिए हम इसे बोलते हैं स्केलर क्वांटिटी। नेक्स्ट प्रॉपर्टी है चार्ज इज़ ट्रांसफरेबल। मीन्स कि चार्ज को आप एक बॉडी से, लाइक ये दो बॉडीज़ हैं, तो इनमें से जैसे Q1 Q2 है, तो आप एक बॉडी से दूसरे बॉडी पे चार्ज को ट्रांसफ़र कर सकते हैं इन द फॉर्म ऑफ इलेक्ट्रॉन, ओके। लाइक वी विल सी इन द नेक्स्ट प्रॉपर्टी विच इज़ क्वांटाइजेशन ऑफ चार्ज, ओके। नेक्स्ट आपका प्रॉपर्टी है चार्ज इज़ ऑलवेज एसोसिएटेड विद मास। इसका क्या मतलब हुआ? तो देखिए, इसका बेसिक मतलब ये है कि जब भी आपका मास प्रेजेंट है, मास इज़ नॉट इक्वल जीरो, देन ओनली वी कैन से अबाउट चार्ज कि चार्ज जीरो होगा कि नहीं होगा। इफ़ द मास इज़ जीरो, then we will not talk about charge, because if the mass is not present, like if the matter is not there, it means the charge is not there, charge can't be exist, okay. Now this is our third property. Now charge is conserved, means चार्ज को आप ना तो फॉर्म कर सकते हैं ना रिमूव कर सकते हैं। इट मीन्स कि आप चार्ज को सिर्फ एक बॉडी से दूसरे बॉडी में ट्रांसफ़र कर सकते हैं बेसिकली। जैसे हमें कई बार शॉक लग जाता है, तो हमारे थ्रू जो है वो लाइट का जो चार्ज होता है वो किस में जाता है? ग्राउंड में चला जाता है, अर्थ में चला जाता है। बेसिकली क्या हुआ? चार्ज ट्रांसफ़र हो गया, बट चार्ज ना तो फॉर्म हुआ ना रिमूव हुआ, तो चार्ज वहीं है, कंजर्व्ड है, ठीक है। नाउ नेक्स्ट प्रॉपर्टी इज इनवेरिएंस ऑफ चार्ज। तो बेसिकली द न्यूमेरिकल वैल्यू ऑफ एलिमेंट्री चार्ज इज़ इंडिपेंडेंट ऑफ वेलोसिटी। कि वेलोसिटी पे डिपेंड नहीं करती कि आप चार्ज को कितना भी मूव करें, बट यू शुड रिमेंबर द चार्ज डेंसिटी रो इज़ डिपेंड ऑन द वेलोसिटी, और वी कैन से द चार्ज डेंसिटी इज नॉट इनवेरिएंट क्वांटिटी। सो वी विल सी इन द नेक्स्ट क्लासेज। नाउ नेक्स्ट प्रॉपर्टी इज charge produces electric field and magnetic field. So the basic thing is here that if the charge is stable, then it produces electric field, and if the charge is moving, then it produces magnetic field. And if the charge is accelerating, moving and accelerating, it means there is some acceleration, not the constant velocity. It means that will produce EM waves, okay. Now the next property is charges resides on the surface of conductor. It means whenever we put the charge on the conductor, like in the this charge we will give in the conductor, this charge will try to repel each other and try to come at the surface of the sphere. So that's the basic property of the conductor. And conductors में काफ़ी सारी properties, जैसे conductor की जो अंदर कभी भी electric field नहीं होता, and if there is a cavity inside the conductor like this is the matter, so we can say in the cavity also there is no electric field because of no charge, okay. Because charge cannot be inside cavity, only charge reside only the surface of conductor. Now the next property is important property, quantization of charge. It means जब भी आपका चार्ज ट्रांसफ़र होगा या फिर चार्ज को हमें किसी बॉडी से रिमूव करना है, then the charge is only can be transferred only in the form of plus minus ne, means where n is a integer. It means charge is only in the form of plus minus Ne. It means the basic lowest unit of the charge is E. E is 1.6 into 10 to the power minus 19 Coulomb. So this is the value of E. Now we have different type of methods of charging. Like first method is by friction. Like if we will do friction on the silk and glass, so then silk will negative and glass will behave as a positive charge. That is by friction. Now by electrostatic induction, by charging induction, conduction. So there are some types of methods for charging, and these are not your syllabus. So but I am giving the names if someone asks you how we can charge on any object. So that is the answer. Now we are going to next topic, which is Coulombs law. Now Coulombs law, in basically when the two charges are there, Q1 and Q2, then your force can be written as like this: the force proportional to Q1 Q2, the product of two charges, and the force proportional to 1 upon r square, the distance. Like we can say this is inversely proportional, is inversely square of the radius, या फिर कहेंगे not the radius, between the distance of the two charges, that is the force. So finally our force becomes proportional to the Q1 Q2 divided by r square. Now if we remove the proportionality sign here, then we will get F is equal to K Q1 Q2 divided by r square, and we can say in the vector form there is an r cap. It means the force is always along the line, or in this we can say always along the distance, the direction of the force. Okay, so this is the force formula in the Coulombs law. Now if you ask the what is the K, so K value is 9 into 10 to the power 9 Newton meter square divided by Coulomb square. And what is the K here in the constant terms? So K is basically 1 upon 4 pi epsilon naught. So I'll tell you that epsilon naught is here that permittivity of space. It means if there is a no any material, then the epsilon naught is the called the permittivity basically of the space. The value of its permittivity is 8.85 into 10 to the power minus 12. So you can remember it. So now the next topic is the properties of this Coulombs law. So basically we are going it. Okay, so we are seeing the important notes of the Coulombs law. So first is that the direction of force is always along the line joining of two charges. So I tell you that only in the force direction is always in the r cap. R cap means the line joining the two charges. This is r cap. Okay, the force is repulsive if the charge have the same sign and attractive of their sign. Okay, it means if the charges are positive positive, negative negative, it means they are repulsive in nature. The force is repulsive in nature. If the charge is opposite, like positive negative and negative positive, it means the charges will attract each other. The force will be attractive in the nature there. The next property is this force is conservative in nature. It means the force is conservative means for del dot F, divergence of F is 0. Okay, and last property is this is also called inverse square law. What does it mean, inverse square law? It means the force is proportional to the inversely square to the distance between the charges. Now we are going towards electric field. So our next topic is electric field. So electric field. Now we have seen what is the electrostatic force, like Coulombs law. So we know that force is in the form of, like, force formula is K Q1 Q2 divided by r square into r cap. So basically whenever we want to find the electric field, so electric field is basically F upon Q, and we can say limit Q tends to 0. It means Q is here the test charge. Q is test charge. So whatever force Q feels, the test charge feels, that is called per unit whatever the unit charge feels the force, that is called the electric field basically. So we can calculate by this way, and we know the force is what on the test charge, K Q and Q naught divided by r square and divided by Q naught, because this is a test charge. So we can cancel out this and we are getting KQ divided by r square into r cap. Now you can feel that the electric field is also inversely proportional to the r square and directly proportional to the charge, and the direction of electric field is an r cap direction, same as the force. Now you have some picture of the electric field line now. So if there is system of charges in the NCERT, there is a topic system of charges. It means there are many charges, not only one charge. So if you suppose Q1, Q2, Q3 like this, so how we will calculate the electric field here? So the basic nature of the electric field is that the net electric field at any point, like this is the P point, and we want to find the electric field at P point. So we can assume that test charge at P point, and we can find the forces and divide by that test charge. But we can say directly also that electric field is a vector sum of all the electric fields. Okay, because this is a vector quantity, this is vector. So if we want to find the force, or we want to find the electric field, then there is only the way that you have to do vector sum of all the electric field and all the forces. All the forces done by the any special, like any particular charges. Okay, so E1 is the electric field of the Q1, E2 is the Q2, E3 is the electric field of Q3. So now you can calculate the net electric field by this way. So we can say like this, that E net is equal to, E1 is what, K Q1 divided by R1 square into R1 cap, and K Q2 divided by R2 square into R2 cap, K Q3 divided by R3 square into R3 cap. It means the net direction will decide by the R1 cap, R2 cap and R3 cap. And if you don't know the two, like if that you have the two vectors, then how you will do the the net product. So if this is a triangle, I am telling you A, B and C. Think like this, these are the two vectors and this is the final vector. So if you want to find the AC vector, then it will basically, if this is theta, so it is AB square BC square 2AB dot BC dot cos theta. This is the basic rule in the vector to find the final vector, or we can say final vector magnitude. Okay, so you can remember it, it will help you in the many questions. Okay, now we are going to do electric field lines topic. So what is the electric field lines? So electric field is like in nature we can say electric field positive charge. By positive charge, electric field lines are outside the charge, we can say in R cap, and this is the direction. And same as negative charge, but the direction is just opposite, like this. Negative charge electric field produces in the like self towards it, but the positive charge field lines are towards away from the charges. So this is the basic diagram of that. Now we are going to forward to see that electric field lines properties. So first property is that electric field line originate from a positive charge and terminate at a negative charge. It means positive charge will produce the electric field lines and negative charge will end the electric field lines. Okay, so we can say if there is only one charge, it means the positive charge will exit the electric field lines, but it will end on the infinite because there is no negative charge. But if there is a negative charge, then the electric field lines end up on the negative charge. Second property is that the number of field lines originating terminating on a charge is proportional to magnitude of the charge. Okay, this is the same thing, like how the electric field is power, like what is the electric field magnitude, it depend on the electric field lines. If E is more, then the lines produced by the electric field is more. The next property is that the number of field lines passing through the perpendicular unit area will be proportional to the magnitude of electric field there. Okay, so this is a basic property you can see. And the next is tangent to electric field line at any point gives the direction of electric field at that point. This will be instantaneous path charge will take it kept there. Okay, this is also a basic property you can say, like if any point the electric field lines, what is the direction of electric field. So if suppose this is the electric field line, so you will draw a tangent on this at any point like this. So at this point the electric field direction is this. Okay, so whenever you want to find the electric field direction by the electric field lines, you have to just draw the electric field tangent on that electric field lines, and you can find the electric field direction. Now next property is two or more field lines can't intersect each other. Why? So see, basic reason of this is that because if you will intersect two electric field lines each other, then it means that at that point there is two electric field direction, because we will draw the tangent of both lines and we will find that there is two tangent. It means there is two electric field directions. That cannot be possible point पे, that is not possible. तो ये फील्ड लाइन, ये प्रॉपर्टी कहती है कि आपकी दो फील्ड लाइन कभी इंटरसेक्ट नहीं करेंगी. नेक्स्ट है फील्ड लाइंस कैन नॉट फॉर्म ए लूप. लूप का मीन्स है, जैसे हमने ये एग्जांपल दिया कि नॉर्थ से साउथ है, तो जैसे मैग्नेटिक जो डाइपोल होता है उसमें नॉर्थ से साउथ की डायरेक्शन में एक मैग्नेटिक लाइन जाती है और इनसाइड द मैग्नेटिक साउथ से नॉर्थ की एक लाइन जाती है, तो वहाँ पे क्लोज लूप बन गया. लेकिन इन द इलेक्ट्रिक फील्ड ऐसा नहीं होता. वहाँ पे सिर्फ पॉजिटिव से नेगेटिव, कि पॉजिटिव चार्ज से आपका इलेक्ट्रिक जो लाइन है फील्ड लाइंस वो जनरेट होती हैं और एंड अप होती है नेगेटिव पे. बट वहाँ पे नेगेटिव से पॉजिटिव अगेन आपका यहाँ पे कोई लाइन ऐसी ड्रॉ नहीं हो सकती, सिर्फ यही अलाउ है. ठीक है. नेक्स्ट प्रॉपर्टी है इलेक्ट्रिक फील्ड लाइंस ओरिजिनेट एंड टर्मिनेट परपेंडिकुलर टू द सरफेस ऑफ कंडक्टर. तो ये मैंने बता दिया था पहले आपको थोड़ी देर पहले कि कंडक्टर जो भी होता है उसकी सरफेस के परपेंडिकुलर यानी एन कैप डायरेक्शन में इलेक्ट्रिक फील्ड लाइंस होती हैं. नेक्स्ट प्रॉपर्टी है यहाँ पे फील्ड लाइंस ऑलवेज फॉर्म ए हाइयर पोटेंशियल, ऑलवेज फ्लो लाइक फील्ड लाइंस जो होती हैं हाइयर पोटेंशियल से लोअर पोटेंशियल तक जाती हैं. ठीक है. इन अ रीजन इलेक्ट्रिक फील्ड इज एब्सेंट देयर विल बी नो फील्ड लाइंस. अगर आपका किसी रीजन के अंदर इलेक्ट्रिक फील्ड लाइन नहीं है, इट मीन्स इलेक्ट्रिक फील्ड ही अगर जीरो है तो फील्ड लाइन कैसे होगी. व्हेन द इलेक्ट्रिक फील्ड जीरो देन फील्ड लाइन कैन नॉट बी देयर. ओके. नाउ वी आर गोइंग टू नेक्स्ट टॉपिक विच इज इलेक्ट्रिक डाइपोल. Okay, electric flux we will discuss later on this topic. Now what is the electric dipole? Let's see. System of two equal and opposite charges separated by a small distance is called a dipole. Means जब भी आपके जैसे एक पॉजिटिव क्यू है एक नेगेटिव क्यू है और वो दोनों चार्जेस सेम मैग्नीट्यूड के हों एंड स्मॉल डिस्टेंस, ये 2a जो है इनका बीच का डिस्टेंस हम 2a कंसिडर कर रहे हैं, ये जब वेरी स्मॉल होता है तो हम इस जो ओरिएंटेशन है इसको बोलते हैं डाइपोल. नाउ व्हाट इज द डाइपोल मोमेंट. तो देखिए इट इज़ डिनोटेड एज पी. इस डाइपोल मोमेंट जो होता है उसको पी बोलते हैं. इज डिफाइंड एज द प्रोडक्ट ऑफ मैग्नीट्यूड ऑफ आइदर ऑफ द चार्ज एंड डाइपोल लेंथ. लाइक पी ये डाइपोल मोमेंट है, तो इसको कैसे लिखा है हमने, किसी भी एक चार्ज का मैग्नीट्यूड इनटू उनके बीच का डिस्टेंस, दैट इज़ द डाइपोल मोमेंट. नाउ व्हाट इज़ द डायरेक्शन ऑफ डाइपोल मोमेंट. तो बेसिकली डाइपोल मोमेंट का डायरेक्शन होता है नेगेटिव टू पॉजिटिव. ये डाइपोल मोमेंट का डायरेक्शन, डाइपोल मोमेंट डायरेक्शन. नाउ ये तो हो गया डाइपोल मोमेंट का डेफिनेशन. अभी देखो अगर अपने को इलेक्ट्रिक फील्ड फाइंड करना हो डाइपोल के कारण, तो देखिए कैसे फाइंड करेंगे. तो बेसिकली मैं लिख देता हूँ डाइपोल मोमेंट इलेक्ट्रिक फील्ड. तो हमारे पास दो टाइप के यहाँ पे ओरिएंटेशन है. पहला ओरिएंटेशन है कि एक्सियल पॉइंट के ऊपर, एक्सियल पॉइंट. On the axial point what is the electric field. So let's see, this is the figure like plus q and minus q. This is minus q. Now I am saying this is 2a distance and somewhere here on the axial line I want to find the electric field. Now just think that what is the electric field of positive q charge. If this is distance, I am saying this is r distance. Now you can think that in this figure we can say that E net is basically E of positive charge plus E of negative charge, because I said you in the system of charges whenever you see in the two charges, three charges, you have to do vector sum. But here the thing is that the direction of the both charges of electric fields that is same. What is the direction of that? P cap. What is the P? Because minus 2 plus, this is the P direction I am saying, because P is the dipole moment direction. Now just tell me what is the E positive. So let's say from positive charge what is the distance. This is till here. Okay, this is till here. So the distance from positive to P point I am writing kq divided by r minus a square. Now E माइनस मीन्स नेगेटिव जो चार्ज है उसके कारण इलेक्ट्रिक फील्ड कितना हो जाएगा, नेगेटिव ऑफ के क्यू डिवाइड बाई डिस्टेंस इज आर प्लस ए स्क्वेयर. Now you can see here that the direction is in the both cases same p cap. Now I am saying one more thing here, that we can take common out kq divided by 1 upon ra minus a square minus 1 upon r plus a square. If we will take LCM of this thing, then we get kq into 4 r a divided by r square minus a square whole square. You can check at your own, okay, and this you will get. Now what is happening here, because I am saying that dipole moment and between the distance of both the charges, that is very small with respect to r, so we can say here a is less than r, so we can put here that a square is also less than r square, so we can neglect this thing, okay. So if we will neglect it, so we will get kq 4ra divided by r square to the power square. So what is this? This is the r to the power 4 basically. So what we will do here, we will say kq into 4ra divided by r to the power 4. One power is cancelled, and this we will get kq into 4a divided by this, you will get r cube. So now it will convert in, we know that dipole moment in this figure, q, one of the charge magnitude, and the between distance is 2a. So we can say directly here k into p into 2 divided by r cube. So basically our net electric field is 2kp divided by r cube in the p cap direction. So this is our electric field on the axial point, okay. Now we want to find the electric field on the equatorial point, so let's do it. So at equatorial point, so we have only two orientation here in the dipole moment. So let's say this is our positive charge, this is our negative charge, so somewhere we want to find like this, okay. You can say this is dotted line, okay. So I'm changing the color of this line like this, minus, this is not the line, okay. So you can say between the charges, you know the distance is 2a, and we want to find the electric field at distance r. So you know that from positive charge the electric field direction is this, E positive, and for negative charge the electric field direction, because negative charge electric field lines are towards its, so the direction is like this. Now the final direction will become in this direction somewhere, okay. So we can say if we know this angle is theta, this angle is theta, then we can say the direction is E positive cos theta and E negative cos theta. This two component, E positive has two component like E plus cos theta, and the other one is E plus sin theta, same as E minus in this direction, E minus sin theta. So we can say that E plus and E minus are same. Why? Because the charges magnitude is same, only the direction is different. So magnitude both the electric field are same. What is that? kq divided by what is the distance between this point P and this point, plus q or minus q. So we can say by Pythagoras theorem r square plus a square same as r square plus a square. Now we will putting this distance r square plus a square root whole square, it means direct whole square. So this is the electric field. Now what we are doing, the net electric field is basically the E positive cos theta plus E negative cos theta. Why we are doing the sum? Because E positive sin theta and E minus sin theta both are cancelled each other. Only the component E plus cos theta, E minus cos theta will survive. So we are adding them. So what is the direction of, what is the, we can say E plus plus E minus, we are taking common out cos theta. Now from the figure you can say cos theta is what? Base upon hypotenuse. So base is what? A divided by hypotenuse is r square plus a square. So you can say this thing. Now you can add up these two fields. So this will get E plus is basically k q divided by r square plus a square, same as E minus, we will get k q divided by r square plus a square. But here the thing is that only the difference is that you will get cos theta. So cos theta value you will put a upon r square plus a square ka root. Now and this is the same thing, so we can say 2kq divided by r square plus a square into a divided by r square plus a square to the root. Now r square plus a square power 1, r square plus a square power 1 by 2, so final power is what? 3 by 2. 2kq a divided by r square plus a square to the power 3 by 2. Now you can say the final electric field is here, E is coming out this. Now we can say again A is less than R, then A square also less than R. So we can neglect it and we will get 2kqa divided by R square to the power 3 by 2, means square cancel with the 1 by 2 power, so we will get 2kqa divided by R cube. Now it's very clear that Q into 2a, again it is what, dipole moment, so we can say this is our K into P divided by R cube. So our net electric field is coming out here, Kp divided by R cube. And what is the direction here? Direction is P cap, but in the negative direction. Why? Because here the electric field is somewhere, we have put it two charges, and electric field is coming here in this direction. In the first figure, electric field is coming in this direction, so this is opposite to that, so we are saying that is negative. Okay, and you can say that Kp upon R cube in general when you find electric field in the equatorial point. So now our next topic from the NCERT book is that charge distribution. So we are going to that, charge distribution. सो व्हाट इज़ द चार्ज डिस्ट्रीब्यूशन? देखो बेसिकली चार्ज डिस्ट्रीब्यूशन मीन्स है कि आप किस तरीके से किसी बॉडी के ऊपर चार्ज को डिस्ट्रीब्यूट करते हो. दैट इज़ थ्री टाइप्स. लाइक इफ़ द बॉडी इज़ लीनियर, it means you can put the charge on the line. Okay, if the body is surface, like this is cylinder, assume this is big, so if you will put the charge on the surface, it means you are putting the surface charge. In the third type, if this is a sphere, assume, then you will put inside also the charge. So you have three possibilities. I'm saying first is linear, second is surface, and third one is volume. So you have three types of charge density. So first, linear charge density, we are talking about linear charge density. So what is that? This is denoted by lambda. So linear charge density is that charge per unit length. Basic definition is this. Now what is the basic meaning of this charge per unit length? So basically lambda is equal to delta Q divided by delta L. If this is our line, suppose this is our line and I put it this charge, so whatever the length is this and whatever charge, so charge upon length. If you have the total charge upon total length and you have the uniform charge density, then you can say Q by L also, and this is for linear charge density. In the second type, we have surface charge density. Surface charge density, it is denoted by sigma. What is this? Charge per unit area. So we are saying charge per unit area. Now we had sigma is equal to delta Q divided by delta A, or you have the you have uniform charge density, then you can say directly Q by A. So this is for surface charge density. And the third one is very important in uses very different type of systems. In this chapter we will calculate the electric field of the sphere also, then we will use this. Okay, rho or sigma, both. If the surface charge density is there, then we will use sigma, and if the volume charge density, then we will use volume charge density rho. So the third one is volume charge density. Now what is the definition of this? This is denoted by rho, and the definition of the volume charge density is charge per unit volume. Now what is the rho here? Delta Q divided by delta V, so we can say Q by V if the charge is uniformly distributed. These are three types of charge densities. Now if we want to calculate the charge from the charge density, then let's see, we want to calculate if the charge from charge density, then the formula is something like this. Q is equal to, in the linear charge density form, lambda into dl. In the surface charge density form, A into sigma into dA. In the volume charge density, rho into dV. This is the formula for calculation of the charge by integration. Okay, by doing the integration of the whole space or whole volume you want to calculate.